Hello and welcome to our video on the surface of the Sun. Today, we'll take a closer look at the Sun's surface, also known as the photosphere. Let's explore some of the fascinating features that make it one of the most dynamic and intriguing objects in our solar system. The surface of the Sun, or the photosphere, is the outermost layer of the Sun's atmosphere that emits visible light. It has a temperature of around 5,500 degrees Celsius and is constantly in motion due to the convective motion of the plasma. One of the most striking features of the Sun's surface is the presence of sunspots, which are dark areas on the photosphere caused by the Sun's magnetic field. Sunspots can be several times larger than the Earth and can last for days or weeks. The number of sunspots on the surface of the Sun varies over time in a roughly 11-year cycle, which is related to changes in the Sun's magnetic field. The Sun's surface is also covered in granules, which are small cells of hot gas that rise and fall due to convection. These granules are constantly moving, creating a dynamic and ever-changing surface that is mesmerizing to watch. Occasionally, the Sun's magnetic field can cause huge eruptions on its surface called prominences, which can extend up to tens of thousands of kilometers into space. Prominences are usually associated with sunspots and are caused by the buildup of magnetic energy in the Sun's atmosphere. When this energy is released, it can cause a sudden burst of plasma and radiation to be expelled into space. In addition, the Sun can also produce powerful bursts of energy known as flares, which can release energy equivalent to billions of atomic bombs. Solar flares are caused by the sudden release of magnetic energy in the Sun's atmosphere and can result in the emission of high-energy particles and radiation. While the Sun's surface may seem like a distant and unrelated phenomenon, it actually has a significant impact on our planet. The Sun's energy drives the Earth's climate and weather patterns, and solar flares and coronal mass ejections can disrupt our communication and electrical systems. In addition, the Sun's magnetic field creates a protective bubble around the Earth called the magnetosphere, which deflects most of the solar wind and high-energy particles coming from the Sun. However, when the Sun is particularly active, it can overwhelm the Earth's magnetic field and cause auroras, or northern and southern lights, to appear in the sky. Studying the Sun's surface is essential for understanding its impact on the Earth and the rest of the solar system. Scientists use a variety of instruments and techniques to study the Sun's surface. It includes telescopes that observe the Sun in different wavelengths of light and spacecraft that can measure the magnetic fields and plasma around the Sun. NASA's Solar Dynamics Observatory, for example, studies the Sun's surface and atmosphere using a suite of instruments that observe the Sun in extreme ultraviolet and X-ray wavelengths. The spacecraft has provided unprecedented views of the Sun's surface and has greatly improved our understanding of the Sun's behavior and its impact on the Earth. In conclusion, the surface of the Sun is a dynamic and fascinating feature of our solar system. With sunspots, granules, prominences, and flares, it's clear that the Sun is anything but a static ball of gas. By studying the Sun's surface, we can gain a better understanding of the forces that shape our solar system and our planet's place within it. We hope you enjoyed learning about the surface of the Sun.